All right, sorry, gang. Here we go. It's Monday morning. Forgive me. I will get started on. I'm just checking in on that chapter 7. I only have 2 assignments in so far, so hopefully you're having a look at it. I only have 2 that haven't looked at it so far, so try and get those in today. I've got a couple in already. The rest of you can get them in sometime later today. All right, let's get at it. So last year, we looked at systems of equations in which we would solve for linear equations, and the solution would always be either 1, where the 2 lines crossed, 2, where there was no solution because you had parallel lines, or 3, there was an unlimited or an infinite amount of solutions because they were the same line. Well, what we're going to look at now is we're looking at system, and so, okay, sorry, before I go to it now, so there were 3 ways in which we could do this to solve systems of linear equations. The first was to graph it and then find out where they intersect. The second was to use that add or subtract method where you would stack them and you would want to get them so that one of the values would end up being 0, and we go through it. So I'm going to do this again today. And then the third way was a substitution method. Well, now what we're going to do is we're going to do the same idea. The only thing that we are going to then add to it is that we're going to use quadratic equations for it as well. So there are 3 distinct possibilities. Again, just the same. Okay, possibility number 1, no solutions. So the line doesn't cross or doesn't even touch the parabola. Possibility number 2, 1 solution in which you've got a point on the quadratic and a point on the line that they actually touch each other, all right, but they don't cross. And then the third solution would be where you have actually 2 solutions, where the line crosses the parabola in 2 different locations. So what we're going to do is we're going to use the 3 methods that we learned last year on how to graph it. So we can use technology for this again, all right? And you can use the technology to check your solution at all times, all right? So it says, so page 334, solve a system of linear quadratic equations graphically. So they give us 2 equations. The first one is y equals 3x squared minus 2x minus 4. So I'm going to rewrite that. Y equals, because we always graph like this, so minus 3x squared. Moving that over. Going to move the 2x over and the 4 over. So we need to graph that first. And then the second one we're going to graph is y equals negative x subtract 2. Okay? So you notice that I took the equation, I made them in y equals form. That way I'm able to use my graphing calculator in order to graph this. Now, I have y equals negative 3x squared plus 2x plus 4. So what I'm going to do then, rather than graph it, because it's not really an easy one to graph, because I can't complete the square to get it into vertex form very easily. I could find my zeros, I suppose. It's probably factorable, minus 12. No, I don't think it is even factorable. So what I'm going to do is I'm just going to use technology to do it in order to do this. So I would take my graphing calculator then. I don't know where I put mine. Oh, right there. Good. So I'd take my graphing calculator. I'd go y equals, and I would put negative 3x squared plus 2x plus 4. I graph it. Then I graph negative x minus 2. And then I'd find out where they intersect. And to me, it looks like there are 2 intersection points. So I just want to open this. Oops. Of course. Okay, so I'll draw this graph, the same graph on here. Okay, so I have y equals negative 3x shift squared plus 2x plus 4. So there's graph number 1. I'm not sure you can see it all that well, but I'll put it up. Y equals negative x minus 2. Graph there. Okay, so I have 2 key points. Again, I'm sorry if you can't see this all that well, but the intersection points are right there, which looks like negative 1 and negative 1, and the other intersection point is down here, which looks like 2 and negative 4. Yeah. Okay, so those are my 2 intersection points. Well, what do those 2 intersection points tell me? All right, so what I would do then is, what I found out, obviously, is where the 2 intersect. And my 2 intersection points I had were negative 1, and 2 and negative 4. So what that means is if I substitute those in to my equation for x and y, the left side of the equation is going to equal the right side of the equation for both equations. All right, they're going to satisfy it. So if you look at squared minus 2x minus 4, and that should equal 0. All right, so let's put in negative 1 and negative 1. So I got a negative 1 here, plus 3 times negative 1 squared minus 2 times negative 1, subtract 4. That gives me negative 1 plus 3. That would be plus 2, subtract 4. Okay, so I would end up with 0 equals 0. So I know it works for negative 1 and negative 1. I would do the same for 2 and 4. Negative 4. Okay, to find out if both of them work. And because I graphed them and I use technology to graph them, it's going to work. All right, we know that that's going to work for us. Okay, so the first thing that we're doing today is we are just simply graphing. Now, if you look at example 2, not only are we graphing a linear and a quadratic, well, page 335, example 2, is a quadratic and a quadratic. So what are the possibilities that I can have here? Well, the possibilities between 2 quadratics now I can have 0. They don't touch. I can have 1, where they touch at the vertex, or I could have 2 possibilities where they both cross each other at the same 2 coordinates. Okay, and again, this whole 8.1 is just simply using the graphing calculator to do it. Okay, and then when you graph it using the graphing calculator, what I'm looking for is, especially with quadratics, find the vertex. So find the maximum or minimum value using your second function trace or calculate. I'm looking for the intersection points for sure. And you can or you don't have to. If you've got the intersection points and the vertex, that's fine. You may want intercepts. You may want your x-intercepts or your roots in there as well, depending on what the equation says. Okay, so again, if you look at 335, I'll simply graph 335 right now. I'll do it again on the Graphmatica here. Just got to delete the graphs. Okay, so equation number one. I'm looking at example 2. Equation number 1, so y minus 3x squared plus 12x equals 16. Y minus 3x squared plus 12x equals 16. Move that up a wee bit. Okay, and then the next one is y plus 4x squared minus 16x equals negative 12. Great first example. I'm sure it may be difficult for you to see again, so I'll explain it. But when you graph the two of them, it looks like they touch at the vertex. Can't quite get it on exactly, but it looks like the solution will be 2n plus 4, which is the vertex for both of those two graphs. Okay, so it says isolate y in the first equation. So again, you would have to change this to y equals. So I would add the 3x squared minus the 12x to the right side in the first equation. In the second equation, I would subtract 4x squared. I would add 16x to the right side. So I would get both of them as y equals, and then I would graph them with the graphing calculator. All right. Okay, so I'm moving pretty quick here. Anybody have any questions or need me to slow down? Just chime in on the unmute yourself. Okay. Yeah, they're touching at the vertex. So go ahead.
Can I put like y equals 3x squared with like 12x plus 16?
Okay, hold on. Let me look at that again. Okay, so I would have y equals, here, I'll write it on the board so you can see it, Amber. So that would be my y1.
Yeah.
And my y2.
Oh, I forgot. Oh, okay. I forgot the x on the 16.
Okay, yeah. All right. Now, just because, you know what? Just because I'm going to work with these two guys for a second here, okay? And I want to show you how this works. So I got, what was it, 3x squared, subtract 12x plus 16, right? Let's complete the square. Now, I'm not asking you to do this, but I want to refresh your memory a little bit, and I want you to see something when it's all said and done. So brackets first, right? Factor the 3 out. So I got to factor the 3 out of those. I plus a blank, add 16, subtract 3 times that blank out here. Half the middle term, is 2 squared, gives me 4 equals 3. X minus 2 all squared. 16 subtract 12 is 4. So looking at that right now, okay, my vertex for this guy is 2 and 4. All right, so let's take the second equation now. Y equals negative 4x squared plus 16x minus 12. All right, factor out. I get negative 4x squared minus 4x plus a blank, subtract 12 minus negative 4 times a blank, 2 squared, 4 here, equals negative 4 x minus 2 squared add 4. Vertex 2 and 4. So now that I see that I have a common vertex, I know that there's only one possibility for a solution in this guy. Okay? There's only one possibility for the solution, and that's 2 and 4. All right? And that's how come when my graphs, I look at them, this one opens down, that's the negative 4 one. This one opens up, that's the plus 3 one, and they're joined at the vertex. So there's only one possible solution for this. Okay, and again, I'm not concerned about completing the square right now. And we don't really need to use it. It's just to show you how the vertices ended up being the same for it. Okay? So the last thing that which is fine, like I don't think you're going to have any issues graphing. I think the graphing part's going to be okay. Again, this last part might be the part that'll be difficult, and that's you finding your own equation. Okay? So let's look at working example 3. Two numbers have a sum of 17. Okay, two numbers, x plus y, and they add, and they have a sum of 17. So there's equation number 1. That's straightforward. The square of the first number plus 5 equals the second number. What are the two numbers? So the square of the first number, x squared, plus 5 equals y. The square of the first number plus 5 equals the second number. So this one I'm going to convert to y equals negative x, add 17. That'll be my y1. And my y2 is x squared plus 5. And then we want to find out how many solutions we have for it by graphing the two. Okay? All right, so we had x plus y equals 17. Ooh. Okay, and then the second one was y equals x squared plus 5. And if you notice, my grid range is a mess. There we go. Okay, so terrible colors. I apologize again. I can't pick the colors on this guy for some reason. So anyways, Here's intersection point number 1, which looks like it's at 3 and 14. And intersection number 2 looks like it's at -4 and 21. So those would be my 2 intersection points. Okay. Now, tomorrow, we're going to solve these questions. And to solve these questions, we're going to use one of the 2 methods, whether it be substitution or addition and subtraction. So I'm going to show you something right now, which we're leading to. So right now I have y equals -x plus 17. I also have y equals x squared plus 5. So that means that I can let these two equations equal each other. So I have -x add 17 equals x squared add 5. Because if this y is equal to that and that y is equal to that, I know that they're equal to each other. I go 0 equals x squared plus x minus 12. 0 equals x add 4, x subtract 3. So that gives me, -4 and 3 would be my x values. Okay. I substitute -4 into there. That gives me y equals -4 add 17. Y is equal to 21. So my first solution then would be -4 and 21. Do the same thing again. Y equals x squared plus 5. That's equal to 3 squared plus 5. Okay, 9 plus 5 is 14. So my second one would be 3 and 14. So that's where we want to go to tomorrow. All right, is solving using algebra in order to do it. All we need from you today is to use your graphing technology and find out what those 2 intersection points are. Okay, and just a quick refresher with the calculator so that we remember how to do it. And so to find the intersection points, I use second trace. I find the intersect on it, and basically all you need to do is move your cursor close enough to one of the 2 points and then hit enter 3 times. Okay, and then to find the second one, you do the same thing and just move your cursor closer to the second point. It'll say first curve, second curve, and then go, and then that's how you do it. Okay, so you just use your cursor to do that. All right, so that covers all of 8.1 for today. And again, you're basically, excuse me, you're basically just using technology to solve it. So if you look through question 3, 4, all right, those are all graphing. 5 is graphing as well. Okay, so you're just working on revamping your skills that you took in grade 11 on how to graph. All right, in grade 11 applied, we do just lines. We don't use the quadratic and a quadratic or a quadratic and a linear. So this is the first thing that's basically new to you. All right. Are there any questions right now pertaining to?
I just have a question about the example we just did. You solved for x, you got -4 and 3. How did you know which equations each number went with?
Doesn't matter, because remember, if it's for both of them, it's got to work for both of them. So you can use either one and get the right answer. Notice in the first one for -4, I use the first equation. In the second one, I use the second equation for it. So it'll work for both of them both times. It has to, because they're both they both satisfy the equation because they are on the actual graph. Like when I write an equation out, like this equation here, x plus y equals 17. Well, what are x and y? X and y are all the coordinates on that line, on that very specific line. That's what x and y are. So it doesn't matter which number or which value I pick. When I put it on that line, the y value and the x value have to add to give you 17. Okay, so it doesn't matter whether you use the first equation or the second equation. It has to work for both of them because that's where they intersect at. Okay? Any other questions about that this morning?
I have a question that's about like 7 chapter 7.
Okay, as long as it's not on your assignment, I'll answer it.
Yeah, so just say, like, this is not an example on it, but like, say if there's like numbers in between like the line brackets or whatever, and you know how you have to like make two cases because you don't know if they're positive or negative, right?
Okay, yeah.
When you have to make it negative, you just put like brackets around your like numbers you had, and then
Yes.
negative on the outside.
Yes, because the reason I do it that way, Amron, is I need to change both the signs or all of the signs. So I have to stick that negative on the outside of the bracket and then distribute. That's the first thing I do is distribute it through at that point.
Okay.
Yeah.
Sweet.
Okay. Any other questions this morning about whether it's 7 or what we just did? Okay, I'm going to leave you open for 15 minutes. Please start in on page 338, 339. I know some of you have not been able to finish that assignment yet, so if you can get that done as well, by all means, get at it. Okay. I think I marked the ones from last week. I will get that back to you today. I don't have a final. Last week we talked about the marks on Power School. There's a meeting tomorrow to discuss what happened last week. So I'm hoping that we're going to maintain, but if we don't, then I'll have to figure out another way of getting them back to you, probably through assignments on Teams. But that will